Multilabel classification. In the last few lectures, we were mainly focusing on different loss functions that are used in machine learning. What all did we learn? We learned about regression loss functions. After that, we learned about different classification loss functions. Inside classification loss functions, we had seen that there is binary classification for which you use certain loss functions. Then we learned about multi-class classification for which there were some particular loss functions. After that, now we are moving on to multi-label classification. What is the difference between multi-class classification and multi-label classification? The difference is, in case of multi-class classification, you will have a lot of classes. Let us say class A, class B, class C, class D. But out of these classes, only one class will be the correct class and all other classes will be wrong classes. So whenever you get an input, if this is your input, this input will belong to only one among these four classes. That is when you call it as multi-class classification. But what about multi-label classification? In this case, this is like those multiple answers correct questions that you would see in JEE Advanced. Here, when you have all these four classes, it is possible the same input may belong to multiple classes. Maybe it belongs to class B, class C, as well as class D. It is also possible that maybe it only belongs to two classes. This is also not. So all these possibilities are there. It may belong to only one class. It can belong to two classes, three classes, four classes, or whatever number of classes. This is when you call it as multi-label classification. In this lecture, we are going to see which loss function do you use when you want to do multi-label classification, and using this loss function, how do you actually do classification? These are what we are going to discuss. Okay, so let us start with this lecture. In multi-label classification, first thing you have to understand, we already discussed that input can belong to any number of classes at the same time. We'll see the terminology. First of all, K is the number of classes, the total number of classes that you have. This is what we are calling as K. If K is the total number of classes, then how should your output look like? Let us say there is a model that you're having. This is your model. You gave some input X to your model. Then what happens? X is your input. If X is the input, what should the model output? Model should output something, some value corresponding to each class. If you're having K different classes, then the output will be a vector Y cap. What will be the speciality of this Y cap? This Y cap will have K values. Let us say Y1 cap, Y1 cap, Y2 cap, so on up to YK cap. So this vector Y cap, this is the output of the model. So when I say output, this is the logit or the raw output. What is logit? Logit is raw output that is coming out of your model. Whatever your model is outputting, you're directly seeing what value is that. That is what you call as logit. So it can take any value from minus infinity to infinity. It does not specifically signify any probability of class or something. It is just a number. That is why we are calling it as logit. Next step is, once you get the logit, you should have it in some sort of an interpretable format. Let us say it is belonging to this class. How do you understand whether this input belongs to this class or not? For that, you have to convert this logit into something more meaningful. That is what is probability. So how can you convert this logit? This logit, each of these values are logits, Y1 cap, Y2 cap, etc. How can you convert these to logits based on whatever we learned in the last few lectures? We know that you can use sigmoid function in order to convert this into probability. So let us say probability for any of these particular YKs. Let us see how to find probability. I'll call it as PK. This is probability corresponding to one particular YK. Okay, maybe Y2 cap or Y3 cap, something. For this, you have to take sigmoid of yk cap. And what is the sigmoid? We already know this. This is 1 by 1 plus e power minus yk cap. This is how you calculate sigmoid. What is the speciality of this sigmoid? This will be a value between 0 and 1, which means you can interpret this as the probability. So using this probability, you can say whether the input belongs to this class or not. If the probability is high, you would say, okay, this input belongs to this class. If the probability is low, you will say it is not belonging to this class. This is the logic. So at this point, you know each probability pk can be interpreted as the probability that label k. According to pk, you can say that label k is the right label for this particular class or not. This is what you can say from it. So that is why we are using sigmoid. Next thing is, which loss function should you use? This is the main question. In case of binary classification, we had seen binary cross entropy. This was very successfully used. When we came to multi-class classification, we used categorical cross entropy or maybe sparse categorical cross entropy, and these all were used successfully. This time, categorical cross entropy won't be good enough because we have a situation where it is not just one class, but it may belong to multiple classes. So then categorical cross entropy cannot help you, because categorical cross entropy can help when you have only one among these classes as the right class. So what is the solution? The solution is very simple. It is simpler than you would expect. The simple solution is that you won't think much. You would simply use binary cross entropy. But where did we initially use binary cross entropy? When we wanted to do binary classification. What we are going to do here is, we are going to see this multi-label classification as a set of binary classifications corresponding to each label k. That is, you have class 1, class 2, class 3 up to class k. For each label, you will take it as a separate binary classification problem. It will say each of these binary classification problems will tell you whether input belongs to this class or not. Input belongs to this class or not. For each of these, you have a separate binary classification going on. So that binary classification is simply going to tell you, is this class does it belong to this class or not? This class or not? Like this, you are going to handle multi-label classification by considering it as a set of binary classification problems. This is the logic. Now that you know it is going to be a set of binary classification problems, you already know loss function binary cross entropy is good enough. But what is the difference? What is the difference when you're using binary cross entropy for multi-label classification? Let us see this. What difference is there? How should you handle it? What we'll do is, we'll build this from the beginning. First problem, I told you there are a lot of binary classification problems, each one belonging to each class. What we'll do is, first we'll take one of these problems, then we'll unify all these and find out the final loss function. Okay. What we'll do is, for one class k, let us say for one particular label k, the loss function can be written as, for this label k, you will write Lk is equal to, we are going to use binary cross entropy formula, nothing fancy here. What is binary cross entropy? We are using same formula here, minus of, you know, your actual output, that is the expected output is y. So whatever is y cap, this was the logit from the model. Then you had a probability pk. I already told you x is your input and then y is your output. Output in the sense expected output. So using this y you want to model. So y for each class k, what will this y be? It will be something like this, y1, y2, like this up to yk. This vector is what you call as y. In case of y cap, you had y1 cap, y2 cap, etc., which is the logit from the model. But this y, this will have y1, y2 up to yk, and all these will be either 0 or 1, because 0 would say it belongs to this class, it does not belong to this class, and 1 will say it belongs to this class. But this time the difference is this is not a one hot vector. In previous cases we had seen this vector y was a one hot vector, but in this case, because it is multi-label classification, it will not be a one hot vector. It can be something like this. Different classes can be included, something like this. Okay, it will only take values 1 or 0. So for the loss function of one particular k, we'll consider that one particular yk, and then we'll form binary cross entropy formula. How are we going to use this? This will be yk log pk, that is the probability of it belonging to this class according to the model, plus 1 minus yk log 1 minus pk. See, if you are confused about how I'm writing this formula, please refer to binary cross entropy lectures. There you will understand this in detail. We had explained in detail on how exactly this formula comes, what is the logic behind it and all. Here if I explain it, it will simply take time, and moreover for those who had already watched the previous lectures, it will be a repetition. So we have directly written the formula here. You can go back to the binary cross entropy lecture and understand in detail how this formula is coming up. So this is just the normal binary cross entropy formula where yk tells whether it belongs to that class or not. So it will be 0 or 1. This pk is the probability that it belongs to that particular model according to the output of the model. Okay, that is the difference. Yk is what is already given, and pk is what model has told us. The model told us that this is the probability, but yk is the real point of whether it belongs to this class or not. And then 1 minus yk log 1 minus pk. So 1 minus pk, because if pk is the probability that it belongs to the model according to, belongs to this class according to the model, then 1 minus pk is the probability that it does not belong to this class. So that is the logic used here. This is the loss function for one particular label. But we know that there are k different labels. For each of the label, you want to calculate this loss, and then you want to average it. How can you do that? Let us say you're considering all the k labels, then how will your loss function look like? Your loss function for one particular sample will be 1 by k sigma k is equal to 1 to k loss function for that particular sample. That is the LK we have here. So what are we going to do? That LK we are going to substitute. Then this will be minus 1 by k sigma k is equal to 1 to k. Then I'm just copying this here. Yk log pk plus 1 minus yk log 1 minus pk. So this is what you will have as the loss function considering binary cross entropy separately for each label. Then you average all those, then you get this loss function. One more point. Generally, when you are training in neural network, what will happen is, or training any model, what will happen is, you will have a lot of samples. You won't train it with a just single sample. This one sample, this is the loss function. You will generally have n different input samples. So using all these n input samples, you are going to train your model. When you train using n input samples, then the final loss function will be, I'll write it as loss function binary cross entropy. This is for multi-label classification case. What will happen? You'll say 1 by n sigma I is equal to 1 to n loss function of that sample. That is the loss function here. So if I substitute it, what happens? This will be minus 1 by nk sigma I is equal to 1 to n sigma k is equal to 1 to k. What will be inside? This time I have to write yik, that is the label corresponding to the ith sample and then kth class in that sample. Okay, yik log pik plus 1 minus yik log 1 minus pik. So this is how my loss function will look like. This is the final loss function considering binary cross entropy separately for each label, and that averaged out among all the k labels and for all the n different samples. This is the final loss function. One more thing to clarify, I got the loss function. So what is this loss function used for? Let us say you have this mod, this is your model. While you're training, each input example will come here. It will produce some output y cap. You will compare this y cap with actual label y. Then you will understand there is some loss. That loss is calculated using this loss function formula. And then you have to back propagate this loss through the model. And during this back propagation, you are going to train theta, the parameters of the model. This is how training happens in machine learning. Using this logic, when you train the model, finally you will have a perfect or whatever is the trained machine learning model. Once you have the trained model, the final model, how are you going to actually do multi-class classification or a multi-label classification? How are you actually going to do this? This is what we are going to discuss next. Let us say for one particular example, you got pk, that is the probability for this label k according to your model. If this is greater than or equal to 0.5, then let us say you will say this belongs to class 1 and class k. For this pk, if it belongs, then you will say it belongs to class k. And if your probability pk is lesser than 0.5, then you will say it does not belong to class k. It does not belong to class k. This is how you are actually going to do multi-label classification. You have the model, you have model's output, then you will calculate probability corresponding to each class k. Then you will see that for one particular class k, how are you going to decide whether this class is actually the class to which it belongs or not? You will see whether the value here, the probability pk, if that is greater than 0.5, you will say yes, it belongs to this class. Otherwise, you will say no, it does not belong to this class. Similarly, you will do for each of the k classes. And what output will you have? Your model would at this point tell you clearly it belongs to these classes and it does not belong to these classes. So for each of the sample, your model will be able to provide this information. This is how you are going to do multi-label classification.